This video is the fourth in a series of 5 videos illustrating the MICP user data tool available in CARP. Please view all parts to get a full demonstration of the tool's use and capabilities. In this video we will illustrate the deviation worksheet of the tool. In this worksheet we compare the measured MICP curve with MICP curves predicted from Leverett, Thomeer and Lonoy averaging methods. This is carried out by comparing the deviation of predicted curves versus measured curve at different pressures and associated heights above the free water level. In other words, we measure the prediction error of the different averaging methods. This worksheet is largely built on the input data from the MICP worksheet, which was presented in part 2 of this video series. Cell B8 shows the applied permeability as input to Thomeer and Leverett methods. The permeability to be applied can be chosen from cell B7 and can be user-defined, predicted based on expected value, predicted based on probability, or Swanson pore type dependent. The user-defined permeability, which usually is a measured value, can be entered into cell B11. The predicted values are automatically derived from other prediction tools in CARP. If predicted probability is selected, the probability can be selected from cell B12. In the density input section, the densities of gas, oil and water can be entered. These are optional and only required if the prediction error of the sample is required, based on its height above the free water level. Results are presented in cells with green color and in the chart. Column D gives the height above free water level for a given pressure as given in column C. Columns E to G gives the predicted mercury saturation for the Thomeer, Leverett and Thomeer methods, and the respective deviations from the measured data are given in columns H to J. The prediction errors are calculated for the pressure interval of 10 to 2000 psi. These deviations or prediction errors are presented in the graph. The zero line on the y-axis represents no deviation to the measured data, whereas negative and positive values represent underestimated and overestimated water saturations respectively. The x-axis represents the capillary pressure, which reflects the height above free water level. The chart can thus be applied to visualize prediction errors for different averaging methods at different heights above the free water level. The height is dependent on fluid-gas composition. The overall deviation or prediction error can be calculated in 2 ways, either as an average or as an average absolute value. Average deviations for the different averaging methods are given in cells B25 to 27. The lower the number, the less overall deviation from the measured data. Negative numbers reflect an overall underestimation of water saturation, whereas positive numbers reflect an overall overestimation of water saturation. Average absolute deviations for the different averaging methods are given in cells B34 to B36. The absolute deviation will always be a positive value and does not give any information on the overall prediction trend. That is, no information is given on whether the prediction in general overestimates or underestimates water saturation. The lower the number, the less deviation from the measured data. The sample's capillary pressure for different fluid gas compositions and based on a height above free water level or free oil level are given in cells B40 to 43. These pressures refer to the chart and show the sample's actual prediction errors for a given reservoir type.